previously we looked at the Caesar cipher, and we've also looked at Atbash, right? We did Atbash and Caesar cipher, both using a string replace method. However, we then looked at operators, and instead we used operators to create a more efficient way of doing Caesar cipher with a loop. We can do that same thing with an Atbash cipher. So I'm going to open text edit, and I'm going to do something fairly similar to what I did with the Caesar cipher. Now with the Caesar cipher, if you remember, I had the user put in some clear text. Well, that's their message, right? They got to define a shift value, so how much is it going to shift the alphabet by? And then it created a empty string to store each encrypted letter, and then it started this loop, right, where it converted each letter into a number, added the shift value, converted it back, stuck it in that empty string that I had made, and then at the very end it prints it all out. So we're going to do something similar. So first, let's define our clear text. So input, and this can be enter your secret message or whatever. And then we want our empty string. Now we don't use a shift here because the Atbash cipher doesn't have a shift. It always has just one key. Now you could include a shift if you wanted to, but then you're sort of combining the Caesar cipher and the Atbash cipher, which would definitely make a better cipher for sure. Still not strong, but better. So now we're going to actually create our loop. We used a for loop, right? So we did for C in clear text. So what this is going to do is for each letter that the user inputs, it's going to run this loop one time. So if they write hello, it'll run it one time for each letter. So that's what, 5? H-E-L-L-O. Yep, 5 times. And then when it finishes, then it will go to whatever's down here, which for us will be print cipher text, right? So inside of this loop, we want it to first convert the character into a number, and then we need to do a little math, right? So if you remember, when we convert a character to a number, it's not like 1 through 26. It's like 97 or 96 or 98 or in the 60s, depending on if it's a capital or a lowercase. So we then need to subtract 97 from it. Now, if it's a capital, it's a whole different story, and I'm not going to get into that in this video because that's going to take a lot longer to do because you have to set up a conditional, if, then, etc. But I did that with the Caesar program, so if you look at that video, you can probably figure out how to use that same method for this. So we're just worried about lowercase right now. So after subtracting 97, then I can, well, then it gets a little interesting. So now what we want to do is we want to say 26 minus temp, right? So this will make A as 0, right? So A becomes 0, and then we subtract 0 from 26, and then when we convert it back, then it should be Z, right? Because the 26th letter is Z. If this were a B, then it would become 1, right? So it would be 98 minus 97, it becomes 1. 26 minus 1 becomes 25, which when we convert it back should become Y. So if it's C, well, it is C, then this would be 99 minus 97, which equals 2. 26 minus 2 would give us 24, which in the alphabet should be an X. So that's how we're getting that other end of the alphabet. Now we need to convert it back. So we'll take temp again, and each time it's redefining what this temp value is. So this is going to be plus 96, right? Because we need to get it back up to where the actual letters are, right? So 0 through 26 or whatnot is not, it's not the alphabet, it's other symbols and stuff. So this should get it back up to that range we wanted. 1, 2, 3, 4. And then we can tell it that temp is equal to the char of temp, right? So if this is a C, that was the last one we talked about, right? So 26 minus 2 becomes 24. 24 plus 96 is going to give us 120. When that converts back, that should give us that X value, that X character. And now we need to actually add it to this empty string that we created. So cipher underscore text plus equals, because we're not overriding what ciphertext is, we're adding it to it, right? So ciphertext plus equals temp. We could sort of compress this into less lines, but for right now, let's just make sure it works. So let's call this acbash.py, maybe acbash with operators, which gets a little long, but you get the point. If I go to terminal, let's see if I broke anything. So cd desktop, Python 3, acbash, this is where you regret the long name, operators, and of course you have to spell the file name correctly. Enter your secret message. Hello, Sfool. It worked, right? So, well, let's try it one more time just to make sure. I'm pretty positive that that's what it translates to, but let's try it one more time. We can just try ABC to be sure. ZYX. So A became Z, B became Y, C became X. So perfect, it worked. Now I said we could compact this a little bit, right? So instead of like constantly redefining temp like this, we could start to compact a little bit of this. So instead of ord C as its own line, this could be ord minus 97, and we can delete this line now. And not only that, but we could also say that it's 26 minus ord minus 97. All that can be done in one line, so now we can delete all of that. And we can combine a little bit of this as well. So instead of saying temp plus 96 and then char of temp, we could put the plus 96 inside of here, and we can delete this line. And instead of actually having this line here too, we can actually put this where this is. So we can combine those like 6 or 7 lines all into just 2. And if you're not quite ready for that, that's fine. You can have it the longer version. A program that works, but it's a little bit longer, is better than a shorter program that doesn't work at all. Okay, now one little extra bit before we actually run this, or really even before we save it. Keep in mind here that we are subtracting this from 26 before we do this. So this becomes quite a negative number, and we don't really want that. So we do need to put this in parentheses, and then it should be happy. So, and you can try it without if you want, but it'll probably break. So run it again. Hello. There we go. It works. Now, I didn't put anything in for capitals and spaces. So if I run it again, hello there. It worked for the most part. It just replaced it with this little bit, and I suppose that's okay. If you don't want it to replace the spaces at all, you could put an if-then statement in there to check on if this is an alpha character, and if it's not, just to add it by itself to the ciphertext, like I did in the previous video with the Caesar cipher. So there you go, a much easier, much more, well, I don't know about easier, but a much more elegant way of writing an Atbash cipher than having the 26 plus lines of code.